Hello and welcome to the first tutorial in this series. Today I'm going to be talking about the Elixir programming language, which is a dynamic functional language designed for building scalable and maintainable applications, according to their website anyways. So, basic background of this, Elixir was designed by Jose Valim, who was working on Ruby on Rails. So some of the syntax may feel Ruby-like, and of course it is based on the Erlang VM, so a lot of the capabilities will be taken from Erlang, and there is Erlang support that is used within Elixir. As you can see here, it mentions it's Erlang compatible, and it throws out some of the names that Erlang is used for, such as WhatsApp and Heroku, which is really an advantage for this language because it gets to pull from everything Erlang has done so far and reuse it. This is their website. I do recommend you check it out if you're interested in learning more in-depth knowledge to this language. Today we're going to go over a few of the basics, but by no means will we cover every feature of the language, as that would take a very long time to actually go through. So, start off with the simplest thing that we can do in any programming language ever is basically the Hello World tutorial, which I'm almost obligated to do at this point. So we wrote a script, and we will run this by typing Elixir and then the name of our script, which is helloworld.exs. And the extension here is generally used for scripts, and if it was ex, then that's normally a standalone or something that's going to be compiled. And as you can see, it works. We got hello world out here, and all we had to do was io.puts, and then the string that we wanted to see printed out. Now, let's look at how to define functions in Elixir. We will define a module, so all functions in Elixir are going to be wrapped in modules, and you can have multiple modules defined inside of other modules, so you can have potentially you could define, test 2, test 3, and then whatever your last thing is obviously your function, so you'd say like function 1 or whatever. And we define 3 functions here, one of which is private because of the def p. And as you can see, there are no return statements here. It's always just the last evaluated value of the function is return type, is its return statement essentially. So that's kind of useful for control flow. So whatever you do last is going to be what you return. It cleans up things and sort of guarantees that you will return something, and that's sort of one of the facets of being a functional language, is that functions must return something. They can't be a void function like you have in C++ or Java. So this is the most complicated function in this file, and all we're really doing here is we're taking in a presumably a list. That's what I'm assuming is going to happen here. It's any enumerable type can be accepted, I assume, but generally in all the examples I'm going to show you today, it's going to be a list. So we're going to assign the taxes of each item or each price to taxes, the variable taxes. And the way this is going to work is in functional languages we don't have loops, but we do have the idea of mapping, which is basically a recursive function. One of the things I hear most often when I mention this is, the idea of stack overflows and type errors and stuff like that. Building up a lot of calls on the stack is bad, and I agree with that. But in most functional languages, they'll actually build a form called tail recursion, which is where you have a base case, and then your recursion case is basically one call to the function. So it's called tail recursion because at the end you come back and you can follow the calls all the way back up, and so it's like you have a tail and there's no branches in the recursion. For example, if you have a recursive call that calls the function twice, that's not tail recursion because then you have branches in the recursion tree. But the reason I mention this is because in functional languages they will implement what's called tail recursion optimization or tail recursion elimination, which is this idea that basically makes tail recursion into the equivalent of a loop. It does not build up stack frames and uses the same stack frame, which is optimized and saves memory. So just keep that in mind. Functional languages don't have the issue of, generating a ton of stack frames and then causing Stack Overflow errors. Next, now that we've got our taxes, we're going to call enum.sum and concatenate these two lists together. It's the syntax for concatenation is ++. And we're going to return that value. So essentially you're going to get the total for your return type. And that's essentially it for this. So let's see if this works. We'll go in and we'll compile it. So it's going to tell me that I redefined a function because I'd already compiled this previously. And now we will launch the interactive Elixir REPL and start testing some of this stuff. So we'll do test.help and test.cell. You see we get back our value of how much that would be with taxes. Assuming the tax rate is 10%, that would be correct. Now let's just, for sanity's sake, let's say we wanted to call that tax function. It is undefined or private. In this case it is private, so we can see it is defined here, but it's very useful to see that working and kind of understand that if you want to write a bunch of helper functions, you can wrap them in this macro instead of the define function, and you get guaranteed safety, sort of. So next, let's look at a little bit more of a complicated example. Alright, so what we're going to do here is we are going to spawn this into a process, and then we're going to listen for that process's mailbox, which is a construct in Elixir where messages can be passed back and forth between two processes, and there's a receive function, and as you can see it doesn't take any parameters and it matches what it receives in the mailbox and then acts upon that match essentially. And this is a loop, so it'll keep calling itself over and over again. Pretty simple and straightforward. So let's go in here and we will start up the REPL here. The other thing to notice is up here at the top it mentions 4 of 4. That's 4 cores of 4, so it is using all 4 cores of my processor. And asynchronous threads 10, so that's telling me how many threads it's spawned. You can control all these options through various command line options for the IEX, and just thought I'd throw that out there so that you know that it is actually utilizing 100% of your processor as much as it can anyways, with however many threads you let it spawn. So we will compile our function here. You can see that it generated a warning because I didn't put parens on the end of listen, but it will expand that automatically for me. So just thought I would show that it is pretty good about noticing small syntactic errors and issues and sort of letting you know. And if they are suppressed, it will still give you knowledge and warnings that, hey, this may not be what you meant to do, but if it is, then that's fine. So we're going to use the task module. We're going to type in start link and then wrap this in a anonymous function. Okay, so as you can see here, it's going to return a symbol or an atom here called OK, so let's know that everything worked, and then the process ID. So if we actually want to use this, what we're going to have to do is match against that structure that's going to come back, and we'll just bind this to process ID. Yeah, that's good. And as you can see, we got a different process ID because that's spawned another process essentially. It's very lightweight to spawn processes in this language. You can have millions on a laptop and have virtually no issues with that. So let's go ahead and see if we can actually get this to work. So we'll send a message to this process ID, and we will see if it prints out the help message. It seems like it's working. So you can see here it matched help, and then it immediately goes to this clause and it outputs the test help. So let's see if we can get this to work with cell. As you can see here, it did return this. The reason you're seeing this at the bottom, this cell and then the parameters, essentially what's happening with send call is it always returns whatever you sent. So that's part of being a functional language, is send can't just be a void function and hold back. It again has to have a return type, so we're seeing that. And that's about it for what I've got. I'm going to do another tutorial where I'll talk about some of the more advanced features of Elixir later, but I'm also going to do some other languages. I'm going to probably do one over Clojure and Racket and maybe some other languages, just to see what all I can get in now that I've got some more stuff to work on and have a little bit more time. But I hope you enjoyed this video, and if you did, give me a like, or comment below and let me know, and subscribe to the page. That'd be awesome. Hopefully I'll have some more tutorials in the next week or so, but hope you all have a good time until then.